The inverse trigonometric functions. Okay. So, back in algebra class, I don't know. Bless you. If I gave you a function like y equals x cubed plus 1, and I said, hey, can you find the inverse function? What's that? That's right. When we say find the inverse function, what I'm really telling you to do is switch. I'm going to call it the input and output. What you really want to switch is, in this case, is what?
Y and x.
Y and x, right? So your first move would be you write x equals y cubed plus 1. So y cubed is equal to what? Almost. X minus 1. And so what does y equal? Do you know the inverse? What? It's the cube root. You guys okay with that? Okay. So if I say what's the inverse of x cubed plus 1, I guess it's the cube root of x minus 1. So that would be, if this were my f of x cubed plus 1, then what I just figured out is that the inverse function is the cube root of x minus 1. And it's funny because we study inverse functions in college algebra, but I don't feel like we can really do them justice until we get to trig class. And now, there's going to be some sense that's made. Because, we just did this problem where you were talking about how tall a tower is, right? And we used trigonometry for it. We had a bunch of triangles. And in the tower problem, I didn't know h, but I knew one of the angles. And maybe I knew another side or something like that. That you can do. Well, you can imagine a problem where what I know are the triangle side lengths, say 3, 4, and 5, but what I don't know is this angle theta. I might want to find theta. Okay? Well, the first thing you could do is you could write down a trig equation, right? So this is a right triangle, we know that. So what would be a trig equation that corresponds to this? Okay, now that's an equation, right? 3 squared plus 4 squared plus 5 equals 5 squared. That's the Pythagorean theorem. But how about an equation involving a trig function?
Sine of theta.
Okay. Sine of theta is equal to 4 over 5. Right? That's a trig function. And what I told you basically is the output. There's others you could do, by the way, too. You could do tangent of theta would equal what? 4 over 3. And so the idea of the inverse trig functions is that I give you the output, you give me the angle. And some of you have probably seen this before. Your calculator has buttons for inverse trig functions on it. So I want to make sure I show you that. And so if I want to know what theta is, well, for example, I want to solve that first equation there. Sine of theta is 4/5. So the sine button's not going to do it unless first I hit this second key. And if I hit the second key, what it gives me is sine -1. Okay? And that's called the inverse sine. When you type that in, you're asking it to spit out the angle that would give me the sine equaling 4/5. Does that make sense to people? Okay? Let's press enter. Well, it says that theta is 53 degrees. Oh, wait a minute. Or is that 53 radians? I better check what mode I'm in, right? Let's see. The mode I'm in is degrees. If you were in radians, it probably said something a little bit less than 1. Does that make sense? What was it? 0.92 radians. Okay. So if you didn't get the same thing, that's why. Well, good. I kind of like being in a degree mode if I'm doing a physical application, right? By the way, what I did was the inverse sine of 4/5. I want to show my work here. And I got that theta was 53 approximately degrees. Would I have gotten the same thing if I used this equation? You should, right? So let's do the inverse tangent of 4/3. And I'm hoping you guys get the exact same thing. Does that make sense? Now, there's another name that you should know about. It's called the inverse tangent. Sometimes it's also called the arctangent of 4/3. And that's also the same thing. Okay? But if you see the arc before one of the words like tangent, sine, or cosine, what I'm telling you is, hey, I want to go backwards. I want the input to be the number, and I want the output to be the angle. It probably makes sense to you why I was asking you for the domain and range. See, what I'm about to do is I want to study functions like this. Y equals the inverse sine of x. I want to study that function. I want to understand it better. And so one of the first things I am going to talk about is I'm going to talk about the domain, and I'm going to talk about the range. And it should be pretty clear to you that the domain and the range of the inverse sine are going to be related to the domain and range of the regular sine. Right? Because how do you do it? You switch what? The inputs and outputs, the x and y. So here, let's go to this problem here. Again, one more algebra example. F of x equals x squared. Okay, so y equals x squared, right? Oh, here's a question. Can I find an inverse? Talk to someone next to you about that for 15 seconds. That's all you get. I had some people just taking a quick peek. Some people did this. They right away tried it. And then they did this. They got y equals what? Of course, there's a rule.
Plus or minus.
Remember plus or minus? But if I do that, isn't that like two different functions at that point? Let me explain a little bit. I mean, that's a little goofy there. Because here's the thing. What does y equals x squared look like? You guys told me that. It's a parabola, right? And I know that when I switch the input and output, see, the parabola, instead of looking like that, when I go for the inverse, it's like the x-axis and the y-axis kind of shift positions. And so wouldn't it look like this? Right?
It's not a function.
That's a problem. What we really want are what are called inverse trig functions. And for y equals x squared, maybe I should have asked this. Can I find an inverse function? Well, the only way I can do it is if I say, hey guys, we're playing by the rules that only positive numbers are allowed. And by the way, a lot of times that makes sense. A lot of times negative numbers don't have any meaning. And then there's an awful lot of times when they do have meaning. So it kind of depends on the situation. But let's suppose I told you guys, here's an idea, okay? We can restrict the domain. That's the phrase that's used. Restrict the domain. In other words, I know that the domain for x squared is usually all real numbers. But I'm only going to use some of them. I'm only going to use this side. Say that the domain is from 0 to infinity. If that was what I had as a domain, now would I be able to find an inverse function? Yes, you would. The inverse function would end up being this piece, y equals the square root of x. Do you understand the idea? See, the problem was y equals x squared, when I look at the graph, it is not what is called 1-to-1. In other words, it doesn't pass what's called the horizontal line test. So your inverse isn't going to pass the vertical line test, and it won't be a function. Do you guys understand here? Okay. So, here's the game. I have y equals inverse sine of x, and I want to start thinking about it. And in order to think about it, I really have to think about the function y equals sine of x, which we had some nice pictures today that you guys drew. So it's a wave function. It goes right through 0, 0. Okay? And the domain and the range, well, the domain is from negative infinity to infinity, we said. And the range is only from where to where? -1 to 1. And by the way, the fact that the range is only from -1 to 1 tells you something. It tells you that when you do the inverse function, what's going to be true? The domain, right? The domain of the inverse function is going to be what? -1 to +1. And you might say, I still don't quite get that. Why should that be? Let me show you guys something. Hey, we just on the calculator took the inverse sine of a number. Was that number between -1 and +1? It was, right? I mean, you could do other examples. You could take the inverse sine of 1. Oh, here's a question. Quiz yourself and the person next to you. Before I press enter, can you figure out what the answer is going to be? What angle is it going to give me? That'll be so that the sine is 1. Talk to someone next to you about that for a second.
No. So would it be the inverse?
I'm in degree mode. So what did it do? It spit out 90 degrees, didn't it? 90 degrees. But here, I'm going to put it in radian mode, because this is what we work with more often. Oh, there you go. How would you know if you're right? Okay, multiply that by 2. And now you say, oh, that's pi. Yeah, that's one way to get it. Right. Or another way you might get it, you might say, I think that this is pi over something. Maybe I'll divide by pi and see what fraction I'm left with. Oh, okay, it was 1/2 pi. There's a couple ways you can kind of check things like that. But here's what I want to do next. If I say the domain is -1 to 1, what will it do if I do this? Say the inverse sine of 10. It blows up. It says error domain. Now you guys understand what it did? It says you can't put in a number that's greater than 1 or less than -1. If I say, hey, go to the error, I don't know what you're talking about, it's going to say, well, you made your error right here, buddy. You told me to take the sine of 10. You can't, inverse sine of 10. You can't do that. You guys understand? Now that's just the domain. What about the range? Well, at first glance, you'd say, oh, the range is going to be all real numbers, but that doesn't work, because if you were to take this wave and flip it sideways, it would look like this, and that's not a function. So we have a problem. So what we are going to do is we are going to do what I demonstrated earlier. We're going to restrict the domain. And by restricting the domain, we're going to basically create what the range will be. So we know that the sine of 0 is 0, right? And so it probably makes sense to you that if I take the inverse sine of 0, it should be 0. Does that make sense to people? But if you think about it, people could have done it differently. They could have said that the inverse sine of 0 is going to be pi. Does that make sense? Because what's the sine of pi? The sine of pi, that's the regular sine, not inverse, is 0, right? But if you do inverse sine of 0, you get 0. You don't get pi. Again, it's because of where we restrict the domain. And what we're going to do is we're only going to take this little portion of the sine function. And by the way, where are we talking? We're talking about, we're going to restrict the domain to go from -pi/2 to +pi/2. And so we're only really looking, I guess, in quadrant 4 and quadrant 1 for the inverse sine function. And so the range of the inverse sine function is going to be -pi/2 to +pi/2. Maybe one last thing to do is this. I'm going to sketch a graph. I'm going to type in y equals, and I know the graphs of the 6 trig functions, but I'm going to graph the first inverse trig function I'm interested in. The inverse sine of x. Now remember what it's doing. It's going to spit out angles between what and what? Between -pi/2 and pi/2. I don't know how this will do. Let me try just graphing it. That's kind of boring. Let me zoom in a little bit. There it is. It's kind of a strange looking graph, but I guess I should have expected that. What's the domain of the graph? From -1 to 1. And if you notice, see, if I input -2, there is no output. You guys with me? That's an error. If I input +2, there is no output. And what's the range? See, you could calculate a value. You could say, all right, guys, let me calculate a value. Let me plug in, well, for example, 1. And it gives me that number, 1.57. What's that again? That's pi/2. Okay. So maybe we're learning some things. I don't know. I want to show you a little bit what the homework's going to be like. Okay? At least the start of it. So we'll do some homework examples and go from there. Page 841 is where I'm going from. Yeah. Matter of fact, tell you what. So they want me to find the exact value of a whole bunch of different things. Okay? Arc sine, arc cosine, these are all inverse functions. Okay? So let me help you out here. number 2. So page 841, number 2. Well, what do we have? We have the arc sine of negative square root of 3 over 2. Now, I know you guys could do what I did with the calculator, and it'll spit out a decimal. But you notice that the directions say find the exact value. It'll be more fruitful for you if you, instead of using the calculator, go through the following approach. When I see this written down, the output of this function is an angle, right? So let's give the angle a name. What do you guys want to call it?
Theta.
Theta, okay. So I'll call it theta. And what I find is that inverse trig functions are harder to understand than the regular ones. So what I'm going to do now is I'm going to rewrite it as a regular trig function equation. See, if the arc sine of theta of negative square root of 3 over 2 is theta, that means that the sine of theta is what? Negative square root of 3 over 2. Are you with me? And you know what that means I need? How do I figure out what angle I'm talking about? Well, you got it. I'm going to look once again at good old what?
Unit circle.
Unit circle. So where do we get a sine that's equal to negative square root of 3 over 2?
Quadrant 3.
Well, you get it either in quadrant 3 or quadrant 4, right? That's where you get it. I guess you're either pointed here or you're pointed here. Oh, but wait a minute. This is where it's very important that I remember the range. What was the range of the inverse sine function? We wrote it down on the previous page. It was from
Negative pi over 2.
negative pi over 2 up to pi over 2. And I claim this. If that's the range, I'm not going to be in quadrant 3. Does that make sense to you guys? Because negative pi over 2, that would be like if I rotated down here. And positive pi over 2, that would be like if I rotated up here. So the answer, the angle I'm looking for, is not going to be a quadrant 3 angle. You guys with me? So now you just have to figure out, well, I can see the answer at this point. It's that angle. What angle is that?
Pi over 3.
It's, yeah.
5 pi over 3.
Okay. So is it going to be negative pi over 3 or is it going to be 5 pi over 3? Again, I have to stay in this range. And so the answer is going to be negative pi over 3. If you put 5 pi over 3, I totally understand why you put it. But what we have to do is we have to learn the ranges of these 6 inverse trig functions. Okay? And I've only given you one of them so far. So I should really do an inverse cosine. Okay. They give me the inverse cosine of 0 in number 14. That's a nice example. Arc sine or inverse sine mean exactly the same thing. So 14 says arc cosine of 0. That's a nice problem. Let's call that equal to theta. So that means that the cosine of theta is 0. Again, I'm on the unit circle. Where on the unit circle are we when the cosine is 0? Yeah, let's see. Not pi, because that would be... so pi over 2 is one place.
3 pi over 2.
3 pi over 2 is another place, or you might call it negative pi over 2. And how do you pick what the answer is going to be? Well, you have to know, how did we restrict the domain of the cosine function? The cosine function looked like that. And I guess I have to tell you the range. It's in your book, but we're running out of time. The range of the inverse cosine function ends up being from 0 to pi. Which quadrants are we talking about if we're going from 0 to pi?
1, 2.
1 and 2. So if you know that, then you probably know what theta is going to be. It has to be between 0 and pi, so it's going to be
Pi over 2.
pi over 2. And the one last thing I'll tell you, which is really kind of strange, for some of these things, mathematicians haven't even agreed yet what the range should be for arcsecant or arccosecant. So in some of the exercises, they say, hey, use this as your range. And then in the other exercises, they say, no, guys, let's use this as your range. But that's enough for today. It's enough to get you through the homework. Okay, so you guys want me to compute the arc tangent of negative square root of 3 over 3. And so, yeah, I mean, I'm telling you guys, look at the unit circle, right? But the problem is you kind of don't see it right away. Let me ask this. What quadrants are we in? Let me ask this. Do we know when you have y equals arctangent of x, do you guys know the range yet?
2.
I mean, that's going to be important.
2 and 4.
2 and 4? 3 and 4? I think it's 1 and 4. I think it's this. Negative pi over 2 is less than y is less than pi over 2. But I'll tell you what, that's always your first step. You guys, when we're going to compute an arctangent, it's going to spit out an angle. How many people understand what I just said? That's bad. Let me try again. I mean, this should be very understandable. Normally, like when I think of the tangent of theta, theta is an angle, correct? And so when you input an angle into the tangent function, it spits out a number. The output is a number. So when I see this problem, arctangent, that's an inverse function, we're going backwards. We switch the domain and range. And so one of the first things I do is I just call it theta. Does that make sense to people? Okay? So you need to understand that we're going to get an angle. Now there are lots of angles, but I'm telling you that the first thing you have to do is you have to decide, where are we talking? What's the range? What are the possible angles that it might be? And I'm telling you that I believe that the range I'm looking at is between negative pi over 2 and pi over 2. Boom. Page 824 has what I want. A big gray box. I told you guys, you can get stuff out of this book. Look for the gray boxes. Okay? What I want is the top part there. It says properties of the arctangent. The domain. That means you could put any number in you want. The range, yeah, there it is. Negative. Oh, wait a minute. Notice theirs is a little bit different than what I wrote. What do these parentheses mean? Do we include pi over 2, or is pi over 2 not allowed?
Not allowed.
Not allowed. And you might say, why is that? Well, because you can't take the tangent of pi over 2, right? Here's the picture that shows you what's going on. Here's the graph of the tangent function. That's what you guys studied. Well, it's just one fundamental cycle of it. From negative pi over 2 to pi over 2. We restricted the what? We restricted the domain. We don't have all these anymore. We restricted the domain so you can get an inverse function. You switch the input and output, now it looks like this, right? The range is from negative pi over 2 to pi over 2, not including those endpoints. So the range is from negative pi over 2 to pi over 2. Oh, I did put less than. I didn't put less than or equal to. Okay, good. So now, I told you guys, hey, you want to look at the unit circle. Boom. Which side of the unit circle are we on? Well, which quadrants are we in? Either 1 or 4. So that narrows it down a little bit. And I claim, if I know that the tangent is negative square root of 3 over 3, do you think I'm in quadrant 1 or 4? It has to be 4, right? Because remember that what you get are sine and cosine, and they have to have opposite signs if you want to be negative. Here they're both positive. That's not the case. So I can tell you already I'm somewhere in quadrant 4. And now it's just a matter of figuring out which special angle is it. Okay? And by the way, I want to point out that there's a couple things. See, this guy comes up a lot. Square root of 3 over 3. Would you believe me if I told you this is the same as negative 1 over square root of 3? I mean, that's kind of weird. How would you get from the red to the blue, though? That's easier. Yeah, you'd multiply top and bottom by what? Radical 3. That would get you back to the blue. But I'm telling you here that it's actually easier to look at it this way and to remember that tangent of theta is sine of theta over cosine theta. Right? So the sine, well, it's not going to be negative 1. The sine is actually going to be negative 1/2, and the cosine is going to be radical 3 over 2. That's kind of what I'm imagining. And do we have an angle that has that as the sine and that as the cosine in the unit circle? Well, yeah, because remember, the cosine is the x-coordinate. So we got to go down, if this is the unit circle, right, 1, 0, we got to go down here. No, we have to go here. This is the one I need. I remember that radical 3 over 2 in the cosine direction is bigger than negative 1/2, right? Which is the sine. Does that make sense what I just did? And so now I just have to say, what angle is that? Well, it's going to be, theta is negative pi over 6. Did you follow that? You know, it seemed clear until the very end. Am I right? I mean, I get that it's this red thing, and that's about where I got lost. I'm telling you that negative 1 over square root of 3 would be the same as if you took negative 1/2 and divided by square root of 3 over 2. And see, those are values that are very familiar to me.
Did you just like multiply both, like top and bottom by 1/2 or something?
Yeah, you could think of it that way.
Okay.
And I almost don't care. What happens is that eventually after you do this homework the next time, every time you see square root of 3 over 3, you're going to be like, oh yeah, that's one of those special angles. Now, what do you do if you don't have a special angle? Well, you use the calculator, right? I mean, that's what we really do. The only thing about the calculator is it doesn't give me exact values. So I'm going to show you this. Okay. Let's take the calculator out. And let's see. Well, I should probably clear this out. And I'm going to go ahead and type in inverse tangent. So second tangent of, and I need the negative sign. And then I want square root of 3 divided by 3. Close parentheses now. So there I am. What's the inverse tangent of this stuff? Oh, it says negative 30. Oh, what mode am I in? I must be in degree mode, right? I mean, I could switch that. You know, it's funny. It's actually easier in degree mode because you're spitting out angles. I mean, if I was in radian mode and I got this, now I have to change it to degrees, right? Of course, there's an advantage to this. I know if it's one of my special angles, it has a pi in it, right? It's something pi. So if I divide by pi, what do I get? Do you guys know that decimal? Negative 0.16 repeating. If you don't, of course, you can hit the mode button. Oh, no, not the mode button, the math button. And the first choice is, hey, change your answer to a fraction, right? So remember, I divided by pi to do this. So maybe that's enough that you'd say, oh, the answer is negative pi over 6, right? That's another thing you guys can do to help. So 33, for instance, says arc secant of 2. Well, you know the first thing I'm going to write? I'm going to write equals what? Theta, or alpha, or some Greek letter, okay? And then the next thing I like to do is rewrite it as a regular trig equation. Because for me, inverse trig is harder. So what's the regular equation we're going to write? Secant of theta equals 2. But I don't like secant as much as I like another trig function that's related to it. What's the other trig function that's related to it? Right, because we know that secant is 1 over cosine. So if the secant of theta equals 2, do we know what the cosine of theta equals? 1/2. Okay. So now can I get what theta is? Well, yeah, I'll look at the unit circle, and I'll say, where does the cosine of theta equal 1/2? Well, I guess it equals it up here. It also equals it down here. Oh, I skipped a step that I started with last time. Do you remember the first thing we did last time?
The range.
We did the range. Do they tell me what the range is here? For the arc secant? Well, remember, this is the one where they could be different ranges, so I don't know what they wanted, you know? It says find the value. All right, well, this is the calculus-friendly ranges, and the other one is, I'm guessing they went with the first one. So the range, it says, is from 0 to pi over 2, union pi over 2 to pi. Why didn't they just say 0 to pi?
Because it can't be pi over 2.
Can't be pi over 2, right? The picture of arc secant, see, there's an asymptote. When you have the secant function, there's an asymptote at pi over 2, so that's why it can't be. This make sense? So, okay. So anyways, bless you. I mean, I know normally I'd be in either quadrant 1 or 2. Well, it must be in quadrant 1. And so where does the cosine equal 1/2? Oh, no, that's not right. It's this one. This one is the 1/2 and square root of 3 over 2. And so, what do you guys think that angle is?
Pi over 3.
I agree. Pi over 3. Yeah. There's a reason I made you memorize that unit circle right away. We're going to keep using it. Like, forever. Okay? Other questions?
Like 57 or 61.
I thought they were a little tricky.
Do they just cancel out? Is that how they get? That's what I thought.
Let's see. 57. So 57 asked, sine of the arc sine of 1/2. What'd you guys get? 1/2? 61 said sine of the arc sine of 5/4. What do you get? Why don't you get 5/4?
Sine can't be more than 1.
Oh, yeah. Right? Those are important to understand. Another one like this. All right, think, though, before I choose which one. 63 is okay. Well, it's when we get down below, say, an 88, 87, 88 and on, that I think it really gets a little bit hairy. So let me do a few of those. There's a point here that I'm trying to make today, okay? You know, you work out 88, and if you do it correctly, you're going to get negative pi over 3. But if you work out 90, which says the arc sine of the sine of 11 pi over 6, you don't get 11 pi over 6 if you do it correctly, okay? Now, I need to explain how and why we do this. All right? So, the first thing you guys did, and I saw this walking around, was you computed the sine of negative pi over 3 by looking at the unit circle. And what is that? Negative radical 3 over 2. That's right. Okay? I could get that again by looking at the unit circle, rotating down until I get to negative square root of 3 over negative pi over 3, and I look at the y coordinate, and it's negative square root of 3 over 2. That's okay so far? Now, anytime I see an inverse trig function, I try to remember it's an angle. It's going to spit out an angle. And then I say, wait a minute, what is the range? As soon as I do that, what is the range? What are the possible angles it could spit out? Well, anything between what?
Negative pi over 2.
Negative pi over 2
Pi over 2.
to pi over 2. And I'll put closed brackets because you are allowed to take the sine of pi over 2 or the sine of negative pi over 2. I'm in quadrant 1 or 4. I'm in quadrant 1 or 4, and it goes from negative pi over 2 to pi over 2. And so, the next thing I would write, after writing arc sine of this equals theta, I would write sine of theta is, well, negative square root of 3 over 2. And I ask myself, hey, if I'm in this range, which angle will give me negative square root of 3 over 2? Well, I already said this point here is 1/2 negative square root of 3 over 2. And so the theta we want is indeed negative pi over 3. But you might say, well, why didn't that work over here? Let's go through it slowly and see why. First thing I do is compute the sine of 11 pi over 6. Now, what's that? Well, let's see. 11 pi over 6. I should draw a picture of that. What quadrant does it end up in? Yeah, because 11 pi over 6, right? It's almost 12 pi over 6. 12 pi over 6 would be right back where we started, 2 pi. So it's this angle. And what are the coordinates of that point right there?
Square root of 3 over 2.
Square root of 3 over 2, comma, negative 1/2. And so for those of you that think that the sine of 11 pi over 6 is negative 1/2, you're right. I'm going to take the arc sine of negative 1/2. Now, next step. Set that equal to what?
Theta.
Theta. And I will rewrite the sine of theta is negative 1/2. and I'm trying to figure out theta. But remember, the range of the arcsine function is this. Hey, could the answer be 11 pi over 6? Can't be. How come? It's not in the range. It is in quadrant 4, but it's kind of, we're not going to do that as the inverse sine. It is true that for the sine of theta to be negative 1/2, this is where I want to end up. But you know how I'm going to get there? I'm going to go the short way. What angle is that? Negative pi over 6. So that's the tricky part of inverse trig, I think. You have to slow down. You got to say, what's the range? What could the angle be? And then get it from the picture. Does that make sense to people? Mm-hmm. It's the reason that when you came to class on Monday, I had you just start thinking about domain and range. It's essential if you want to think about the inverse functions. Okay? Tyler, go ahead.
Where does the sine of theta equal negative 1/2?
Where does the sine of theta equal negative 1/2?
Or why does it?
Well, okay, I had the equation inverse sine of negative 1/2 equals the angle theta. What does that mean? It precisely means that if you take the sine of theta, it equals what's there. Inverse functions mean you switch the input and the output. So an inverse function spits out an angle. But you can also write it with a regular function. Sine of angle equals the number. Every time I get an inverse trig function, you're going to see me do that. Matter of fact, I'm about to do it on the next set of problems that we do. Let's type inverse sine of negative 1/2. Inverse sine of negative 1/2 into the calculator. This is going to spit out the right answer, right? Boom. How do I know if that's negative pi over 6? Well, I could divide by pi. That might help. Yeah, it's negative pi over 6. It'll never spit out anything else, even though there's lots of angles that, because when we say arcsine, we make it a specific range so you only get one answer. Does that help? Okay. Do you guys have other questions? So, yeah, on the homework, I gave you guys number 203. So let's see. It says the sine of x equals negative 0.721. All right. What are you supposed to do?
Solve the equation using techniques discussed.
Okay.
But I know exactly what technique you use.
Yeah, I didn't really say. It says find x and then approximate the solutions which lie in that interval to 4 decimal places. Okay. So this is a little interesting. I mean, first of all, I want you to understand there are lots of answers. When I say lots, how many? Infinitely many. Okay. The best thing you can do is this. One of them is x equals the inverse sine, or the arcsine we might say, of negative 0.721. That's one of them. That's kind of what Jordan's point was. How do I know, which one I'm going to get? Well, I told you guys that if we're going to talk about inverse sine, we need to know the range. Do we know the range of the inverse sine? Well, yeah, I just did it. It's negative pi over 2 to pi over 2. So I guess what I would say is I can get it from my calculator as long as I type this in. Okay? So let me try that. All right. Go to the calculator. Got it. And let me type in inverse sine.
Green radians.
We better be, right? Because if we're not, it's going to spit out degrees. I'll check that right after. Here, let me check it now. Yeah, I'm in radians. Inverse sine of negative 0.721. It's going to spit out an angle. So it said negative 0.8 radians. Okay? Question, David?
Whenever I put a negative into my calculator, it says I have an error.
Oh, that's because you're not putting the little negative sign, you're putting the minus sign. Okay? And yes, it'll have a problem with that. It's funny because when you do a math homework assignment, who cares? But your calculator has an issue with it. All right. So far, let's draw a picture of what's going on. It's funny how often that's what I tell you to do. Okay. We found an answer. One of the answers is x is approximately, and they said 4 decimal places, right? Negative 0.8052 radians. All right? Well, remember the range is from negative pi over 2 to pi over 2. Which quadrant is this angle going to be in again? Remember, this is an angle. Which quadrant is it in? Yeah, I mean, we know it's going to be in 1 or 4. It's definitely in quadrant 4. So if I draw a picture of it, this angle is somewhere down here in quadrant 4. Okay, negative 0.8052 radians. It's not the best picture I've ever had. I have to admit that. It's okay. By the way, if you want other angles, I can get other answers by doing this. Negative 0.8052 plus 2k pi. What am I doing there? I'm saying if you want another answer, what do?
Go around.
You go around, because that's what 2 pi radians means. And then k is whatever you want. So for example, let me show you that this would actually work. All right, where are we? We're here. I'm going to, just for kicks, add, how about I add 6 pi to it? Okay? I'm going to add 6 pi. There we are. Now that's kind of strange. That's a big number, right? But I guess, and what units is that in?
Radians.
So 18 radians, 18 point. Well, how would I check if that's actually an answer? How would I? Well, I have to take the sine of it and see if I get what? Negative 0.721. Let me try. I just need to take the regular sign of my answer, which I get by hitting second and the negative sign. And it should spit out the negative 0.72. It did. It really was an answer. Okay? Here, instant replay, guys. Let's try this again. Second entry, second entry, second entry. Inverse sine of 0.721 is that. That's the angle I drew. Tell me something else I could add to it and get another answer. 10 pi. So when I say there are lots of answers, you guys understand there are infinitely many answers, right? And how do I check? Well, I'm going to take the sine of that answer, see if it's right. Ha! What if I told you, though, there are still some other answers? There are. The way I can get that is from the picture. There is another place on the picture where the sine of x is negative 0.721. So where would that be?
Quadrant 3.
Quadrant 3. Let me draw it for you. And I'm going to use red because it's the one I missed. There we go. That angle there. Now how the heck do I figure out how many radians that is? Well, it has to be, let me go back. You guys, I'm going to label an angle. Please watch carefully. See that little curvy arrow thing there? That's a rotation or a partial rotation. How many radians is that little curvy arrow? Negative 0.8052 radians. That's what that angle is. Are you with me? Okay, watch this. Guess how many radians that is that I just drew? That's another positive 0.8052. Are you with me? But that's not really the whole angle that I need. I need this one. See if this makes sense to you. Zoop. So what angle is that? I claim that that angle, here, let me show you. I could get it by taking, how do I want to say this? Okay. Let me start off with the way we started before. There's my negative 0.8052. Are you with me? What do I have to add that to? I basically have to add it to pi. The only problem is I don't want that negative sign anymore because I want to add it. I don't want to subtract it. So I'm going to do two steps here. I'm going to take the negative of that answer. So now it's positive. And then I'm going to add what to it? I'm going to add pi to it. When I add pi to it, I get 3.94. So this one is 3.947 radians. That's another answer. And again, you could also add 2 pi k to that, and those would also be answers. More answers. How do I check that these things are answers? How do I check?
Take the sine of it.
Take the sine. Let's try. Let's take the sine of the answer I just got. Negative 0.721. It works. But I claim that now we have represented all of the answers. Oh, one last thing that the book asks you to do, and this is actually not bad. It says, hey, give me all the answers between 0 and 2 pi. All right. Let me do that. So let's see. All answers between, well, it says in the range 0 to pi. Because basically this is all the possible answers you could get, and then you just have to add 2 pi to them, or subtract 2 pi from them to get all the answers. Well, one of the answers would be the one I just found, 3.947. And if you look in the book, that's one of the answers. Another answer, it's funny, they won't give you negative 0.8052. How come? That's not between 0 and 2 pi. So in order to get the answer that I want, you know what I have to do? I have to take that answer negative 0.8052. Where is it? That's how I started. Inverse sine of this thing. And what do I have to do to it? Make it positive. See, because originally we got the black angle by rotating down. That made it negative. I don't want that. I want an angle between 0 and 2 pi. So now I'm going to add what? 2 pi to bring it back to somewhere between 0 and 2 pi. So we take that thing, we add 2 pi to it, and that'll give me the other answer that I'm looking for. So let me add 2 pi. And I guess the other one I want is 5.477. No, 5.478 if we round correctly. Okay, there's all the answers between 0 and 2 pi. Very nice. Okay, problem 132 is worth talking about. So problem 132 says we want the sine of the arc cosine of 3/5. Well, I claim there's an angle there. Where's the angle? What's the angle up there? You don't see it yet, okay? What if I tell you that this guy right here is an angle? How do I know that? Any inverse trig function always spits out an angle. Are you with me? So you know what I'm going to write? I'm going to write that this equals the sine of theta. Are you with me? It equals the sine of theta. Okay? And actually, do I know the range of theta? What do I know about theta? What is the range of the arc cosine? Well, that one I'd have to look up again, but I'll just tell you it's from 0 to pi. 0 to pi. Which means quadrants 1 and 2. Okay? So actually what I would like to do is I would like to draw a picture of theta. I know I'm either in quadrant 1 or 2. Can you tell me which of those two quadrants I'm in? Here's a hint. We just said that theta is the arc cosine of 3/5. Let's write that as a regular trig equation. What am I going to write?
Cosine of theta.
Cosine of theta equals what? 3/5. Now I know you can draw a picture. Let's draw a picture where the cosine is 3/5. Which quadrant will I be in? I'm going to be in quadrant 1. How do you know it's 1 and not 2? It's positive, right? Over here we'd be negative. The cosine is the x-coordinate going on. So let me draw a picture of it. Something in the first quadrant. And if I say that the cosine is 3/5, remember cosine is x over r. So maybe what I'll do is I'll put a 3 here, and I'll put a 5 here, and my theta is right there. That's my theta. Now, normally, you know what you'd have to do next? If we want the sine of that theta, we know that sine, of course, is y over r, right? So you would have to figure out what y is. But you guys all know what y is. What's y?
4.
Okay. Normally you'd have to use the Pythagorean theorem, but we've seen that one a billion times. Which is a nice example if you want to get through it quickly. So what is the answer? What is the sine of theta? 4/5. Boy, that makes it seem easy. Drawing the picture is the key. But I thought I should also do one that maybe isn't so easy, because I hate when they just do the easy one. All right? So looking at these in the same page, what if I did something like 154? Maybe that would be nice, right? So let's try number 154. And what does it ask me for? It asks me for the cosecant of the arc tangent of negative 2/3. Okay. Any guess what the first thing I'm going to write down is? We're going to write cosecant theta because we're trying to remind ourselves, hey guys, theta is an angle. In fact, theta is the arctan of negative 2/3. And as soon as I write down theta is the arctangent, what's the next couple things I'm going to write down?
Tangent of theta equals negative 2/3.
That's one thing. I'm going to write tangent of theta is negative 2/3. I'm going to draw a picture of that in a second. And I'm also going to remind myself of something else. What is the range?
Negative pi over 2 pi.
It's negative pi over 2 to positive pi over 2, and you're not allowed to be either negative pi over 2 or positive pi over 2. Okay? And for the homework, you guys are going to be looking in those gray boxes to get the ranges until eventually you'll memorize them, I'm sure of it. There's only 6. So now I draw a picture. Which quadrants could the picture be in? Well, according to that range, yeah, we're either in quadrant 4 or in quadrant 1. Which quadrant do you guys think I'm in?
4.
I agree, because it's negative. And so I need to draw a picture of this. So I draw my angle. I make my reference triangle. And I guess if this is theta and the tangent is negative 2/3, I'm going to label this guy negative 2 because it's going down. And I'm going to, that's opposite over adjacent. I'm going to label this positive 3. That's right. And I still need to compute r, don't I? So r here, well, let's compute it. We know that r squared is, well, 3 squared plus negative 2 squared. So r squared is 9 plus 4. So r squared is 13. So r is the square root of 13. All right? And now, cosecant of theta is what I'm trying to find. That's the reciprocal of what?
Over sine?
Yeah. And I know that the sine of theta is always y over r. But we want the cosecant of theta. The cosecant of theta would be, I guess, r over y. So now do you see what it is? Well, we did r, square root of 13, over what?
Negative 2.
Negative 2. And so that's my answer, negative square root of 13 over 2. Okay? And I think that's enough. You guys ought to be able to try the homework at this point.